We have to find the sum of series if the sum exists. We have sum of 2 times 1 over 1.1 to power n from n equals 1 to infinity. So we have here infinity series. Let's first rewrite this sum. First, we have to substitute n in our expression by 1. So we have to copy 2, and in parentheses we will have 1 over 1.1 to power 1 plus. Next, we have to substitute n by 2. N can be positive integer from 1, 2, 3, and so on to infinity. So next n is equal to, so we have to copy 2, we have 1 over 1.1 to power 2 plus, again, 2 times 1 over 1.1 to power 3 and so on. Our sum is going to infinity. What else? First term, we can write that this is a1 is 2 times 1 over 1.1 to power first, so it will be the same, we don't have to write. What next? This is our first term, the second, the third. We see that next term after first, how is obtained? We multiply this term by 1 over 1.y, and the second, when we multiply by 1 over 1.y, 1, we will have the third. So we have here infinity geometric progression. One more time, how I get this? Our R common ratio is in geometric progression. How we calculate? We have to take two consecutive terms and divide the second one by the first one. So, for example, A2 over A1. And the ratio is constant. It will be 2 times 1 over 1.1 to second power over A1 is 2 times 1 over 1.1 to first power. So 2 and 2 we see that will reduce. What else? The base is the same, so we copy the base 1 over 1.1 and the power what will be 2 minus 1 is 1, we don't have to write. The same will be when we take A3 and A2. The ratio will be constant. 3 minus 2 give me 1, so the power will be 1, and this will be our common ratio. So because every term after first we obtain by multiplying the preceding term by the constant factor r, this is geometric progression, and the geometric progression is infinity and going to infinity. So next step, we have to check the r. If r, absolute value of r, is less than 1, then we have the series converges and we can calculate the sum. If the r, absolute value of r, is greater than or equal 1, then we have series diverges and we cannot calculate the sum. The sum doesn't exist. So this is for series converges, and we can calculate the sum, and this is for series diverges. And when absolute value of r is greater than or equal 1, we cannot calculate the sum. The sum does not exist. So let's see what we have here. Absolute value of r, so we have absolute value of 1 over 1.1 is less than 1. You can use calculator. 1 divided by 1.1 is equal 0.9090. So we see that this is number less than 1. So because r, absolute value of r, is less than 1, we can calculate the sum of our series, geometric series, and the sum is equal a1 over 1 minus r. So this is equal, we will substitute a1 by 2 times 1 over 1.1, and in the numerator we have 1 minus r is 1 over 1.1. So this is equal, we have 2 over 1.1, and in the numerator what we will have, we can change 1, that this is 1.1 over 1.1 minus 1 over 1.1. So this is equal 2 over 1.1 over the same denominator, so we can subtract, so we have 1.1 minus 1, so it will be 0.1 over 1.1 division, so we will change to multiplication, so we have 2 over 1.1 times, and we have to flip the numerator, so it will be 1.1 over 0.1. So we can reduce, so we have 2 over 1/10, 0.1, so this is equal 20. We calculate the sum of our series because the absolute value of common ratio is less than 1. That's why we can use this formula. We have here series converges. That's why we can calculate the sum. This is my solution.